Submarine friends. Well, remember I talked about making the shaft assembly that goes through the nozzle here and out to the valve to open and close this valve from inside the sub. I'll be able to do it from inside or outside. So this is the shaft I made. It's obviously too long, but I just took a piece of stainless steel shaft from an outboard motor. This is actually the drive shaft technically. And then I took a pipe nipple. Now this is just a pipe nipple that I'm using for experimenting with this whole idea. And then two brass 1/2-inch pipe plugs, again experimenting as well. Worked fantastic. So all you do is you take the nipple, you screw in your pipe plugs, you drill it out. I drilled it out to 1/2 inch, and then I machined it so it was nice and smooth, the bore. And then I machined the propeller shaft to fit the bore with a 2-inch or with a 2 thou clearance. And then I machined in 2 O-ring grooves, and those O-ring grooves line up with each of these brass plugs, which are now O-ring seal fittings. So that just slides on. Now what I do is I locate a horizontal line from when I get the new valve across, and then I drill a hole with my fancy hole saw set. Then I insert this, I cut this off to the right length and make a coupler to the end of the valve shaft. Then I tack this in place. So I assemble it all and then I tack this pipe nipple in place, take it all out, take it apart, and then weld it in solid. Then I just simply screw these guys back in, put the shaft in, and I'm done. If you don't do it that way, you can just put O-rings or machine this, a solid shaft, drill it, machine it, and weld it in there, and cross your fingers that it doesn't distort when you weld it. That's the problem. I've been bit by that. And it really sucks because once it's in there, how do you fix it? So I like this. I've never done this, but this is really looking promising. Well, it works. So what I'll do now is I will replace this pipe nipple with a Schedule 80 pipe nipple, and I'll replace these 2 brass plugs that are modified with stainless steel plugs, and away I go. The reason I want to go to Schedule 80 is because this point right here, front and back, is the weakest part of the entire submarine. So I had a computer analysis done, and this right here is the weak spot. So I don't want to weaken it more, so I have to make sure I have good reinforcement when I drill this hole. So Schedule 80, then stainless steel. Then I take this shaft and I put it in my mill, and I'll just make the end of the shaft square, thread it, drill it and thread it, so I can just put a regular tap valve on it, and Bob's your uncle. But if you just put a lever like this on, I had a submarine with the exact same thing, not this style, but with a rotating shaft coming through here with just a single lever valve. That's a bad idea. I mean, it was a great submarine, but that was a bad idea because I actually had a grad student jump in with me in Lake Tahoe, and he started submerging the submarine because he actuated that lever. So if you're going to do that, you better have a locking mechanism on it, which it did not have. And that was a certified submarine at one time. So it's better to have a round handle so when you hit it, it doesn't actuate. So that's what I'm going to do. I'll machine that square, and I'll pick up a valve so I can get this done. So I'm pretty happy with it. That turned out fantastic. It also helps. I just bought myself some nice new cutters and some tooling for my lathe and for my mill. What a difference. Boy, when you have the right stuff, what a difference. My machining abilities really improve when I have the right stuff. So I'm pretty pleased about that too. So that's it. Onward and upward. Ciao.